Okay, so this is video we're going to do a little intro to antiderivatives, defining antiderivatives. Is an introduction, so we're not going to do the language that maybe in future we'll be talking about. The ideas for an antiderivative that I want to use this video about is the antiderivative. What we're looking for is to find a function f of x where if I took the derivative of that function, I get this big function big f of x that was given. So basically, that's what it's called antiderivative. We're finding the opposite directions. We're going to find a function whose derivative is the function that was given. So in this first example, we can see that the regular rule the more basic rule that we have for derivatives is that, so remember that you know that the derivative of a power function or a polynomial function decreases that power by the n comes down, it's x to the n minus 1. So now I want to go backwards, right? So if I want to have a function here that has a power, and now it's going to become over here, I have to increase the power, right? So that means that my little f that I want to find here, it has to have an x to the 5th power, because that way its derivative, when I take the derivative of this guy, the 5 would come down, and I'll have x to the 4, correct? So that's what I'm going to have. Now I'm not going to have the 5, right? It's not going to. It's not there. So that means my function that I'm looking for maybe has to be divided by 5, because that way, when I do the step above the power coming down and having this to the power of 4, the 5s are going to cancel, correct? So sorry, I didn't wrote this correctly, but if I find the derivative of that, that's what would happen. So it's going to be x to the 5th over 5. The derivative of that would give me x to the 4th. Now the 3 that I have here as a coefficient is still going to stay there, right? Because that way the effect of taking the derivative of this, the 5 would come down, multiply the 3 and get a 15, but don't bother multiplying. That 5 is going to cancel with the 5 in the denominator, so the 3 is going to survive, right? Okay, now for the second part, this is more straightforward, using the same principles. Well, first of all, this negative sign is going to stay there. And now instead of x squared, I'm going to have an x cubed, right? Because now this is going to come, if I take the derivative of this one, the 3 is going to come down, and it's going to be x squared. And look what happened. If the derivative, the 3 is going to come down, and I'm going to have an x squared up here, and that's exactly what I have. So when I find the derivative of this part like that, I get the 3x squared, correct, right? So there's nothing else I need to add, sorry, to this term. Now the important thing to know also when you find antiderivatives is I said we're looking for a function with its derivative equals to the big function f of x. Well, that's not a unique function, because if you remember, if I take the derivative of any constant, I get a 0. So if I did this one plus 3, I would still be the same derivative and I get f, right? If I take that one plus 34, it would still be the same derivative. So I can add any constant here and it would be the correct antiderivative. So this would be my answer. You write it, a general antiderivative would be the 3x to the 5th divided by 5 minus x cubed plus a constant, because if I add any constant here, once I take the derivative, it would disappear, and I will not have it in my derivative. Okay, let's move to my second example. So my second example is here on purpose. It's that. Now I have a big problem, because the derivative has a lot of rules. We can find the product rule, we have the chain rule, we have the quotient rule. Antiderivatives are hard, because this function has a composite function, so it would involve kind of something like the anti-chain rule. And if you think about this for a minute, there's no way I'm going to find a function whose derivative is this. So I'm trying to find a a function g of x with the derivative to be sine of 3x squared, right? You can't see the derivative, sorry. It's going to be not possible, because if you remember the derivative of a sine, well, I can find, well, if I say, well, derivative of sine is cosine, derivative of cosine is sine, so what if I do cosine? The problem is that if you put your candidate to be cosine of somebody, right? It has to be the cosine of 3x squared. The derivative of cosine squared, well, it's not going to work because the derivative of cosine is negative, so we can fix that by putting a negative here. The derivative of the negative cosine would be a positive sine. The problem is that I have a chain rule. So if I did the derivative of this guy, the chain rule says I would need to do the derivative of cosine, which is negative sine. With the negative that I have, it's going to become positive. But then I have to multiply by the derivative of this term, right? And I don't have that. I don't have that. So I would really need this to be 6x times sine of 3x squared. And I can't. So this is not going to work because I don't have this term here. I cannot include an x extra to say, hey, just to multiply by x, it's not going to work. X is part of the function. It's not just a constant that it can move around. So this is not possible to find an antiderivative of this function. I did it on purpose to tell you, well, this is the kind of things that we can do. If I have an x over here, then I can do this because I'll have the same steps that I had before, where this is the cosine of this function u, and the derivative of my u function is 4x. So this x outside helps me to say, oh, then this would work. My candidate here is my h of x would be the derivative sine is a positive cosine, and it has to be the same argument, 2x squared, right? The derivative sine of 2x squared would be, let me check, something's missing here, so let's check what's happening. The derivative of h of x would be the cosine at the same argument, but then times the derivative of that because of the chain rule. So this becomes a 4x. And that's not exactly what I have, but it's not a problem. I have the x. The only thing I don't have is this 4. So if I divide by 4, that's a constant. I can fix that. If I put a 1/4 right here, that would work. Because that way, this constant 1/4 would not be affected right here. And once you keep a track, at that point they cancel, and you get it. Okay. So this is my intro to antiderivatives and how they're going to get complicated in the future. And part of it is because of the chain rule. Okay, this is going to be called u-substitution later, but for now we're just exploring this idea of what do I need to multiply or divide in order to have the complete derivative that I want. Okay, so this is my first intro to antiderivatives.